Yeah, we've got intense 45 minutes. Welcome on my presentation. As you can see, Paula J, quite a complex last name. And I'm from Poland. Just a couple of words to mention. Do you want to add something? You want to come over? No, that's good. Okay, great. Perfect, thank you. As you can see, I'm the CEO of Secure, and the company that I started almost 11 years ago. Right now, just to give you a couple of words, we are spread in between 4 locations: Poland, Dubai, New York, and Switzerland. And we are a group of like 40 people out there, and we do basically all the geeky stuff that I guess you guys do the same, which is cybersecurity. That's why we are meeting up over here. I do have 15 years of experience in the field playing with cybersecurity. This is my hobby, my life, my passion. And together with my team, we are doing a cybersecurity research in various fields. We've written over 200 hacking tools that we share for free, that we use normally for the pen tests. But why not sharing? That's why you're also here. So this is pretty much our background. Now, just a couple of words, yes? So today's presentation, it's going to be fun. One of the most difficult subjects in cybersecurity, I would say, which is a data protection API and data protection API-NG. So different ways how operating system protects our information. And let me tell you something that I personally believe in, and I think so, is that this is a subject that I really think each of us working in cybersecurity should know at least well, because this is how our data is protected in the operating system. So that's what we're going to be talking about, yeah? So difficult subject, but absolutely important. Now, why do we have DPAPI and DPAPI-NG? We're going to learn in the presentation, but NG stands for new generation, and that's something that basically allows us to encrypt data in a little bit different way. We could think new generation means kind of better, but not necessarily really, because DPAPI classic, so the regular one, it's something that the operating system uses anyway. Yeah, so this is basically what we're going to be talking about today. Now, few words basically about myself. If we haven't met before, you probably noticed that I really like to talk. So I talk about different things all the time, including cybersecurity. And I also have a chance to speak at other conferences. Quite recently, I was rated #1 speaker at Black Hat in Asia, which, I mean, it's okay, I'm happy, but it doesn't really matter at the end, as long as there is something useful for you guys, yeah? So as simple as this. So also things like Ignite, things like RSA in San Francisco. So our team and myself, we really like to share knowledge about what we do. So let me tell you a little bit about the research regarding data protection API, because as far as we know, we are the first team out there that fully reverse engineered data protection API. It took us over 2 years to do it, but research in general around data protection API, it's a hell. So basically in Windows, putting this in a very shortened version, you don't have that many standards if it's about how do you actually approach data to encrypt it. So if you have to go through a bunch of levels, and it's like 20 levels to go through, you're wondering what kind of algorithm was used over there. Yeah? So this one is this moment is that, this is that, this is this. So you have to figure out things all the time, by all means, and that's why it's a little bit painful. This is something, by the way, that reminds me of my vacation when I was in Siberia. And I was just traveling around. You know, this is one of these places that you want to go to because there's like sometimes no mobile range. So for IT people, that's sometimes perfect because we are all the time connected. So there's this moment when you're going to get disconnected, and that's the place. And I was having breakfast in the different places. Yeah, so there's like a little restaurant here, someone's house over there, this place here. And I speak a little Russian too, but unfortunately, every single time when I was like asking for something during the breakfast, can I please have scrambled eggs? I was just getting a sausage, and I was asking, for example, for whatever, dumplings, and I was getting scrambled eggs. So I literally could not, and that started to become funny, I literally could not get for the breakfast what I wanted. So there was this restaurant when I get in, or like the place, little place, and in the menu there was a cheese sandwich. Now, how wrong can you go about the cheese sandwich? You can't, right? It's a slice of bread, and the cheese. So I was like, score, I'm gonna order the simplest position in the menu to make sure that I'm gonna be successful finally in ordering my breakfast. So when I asked for the cheese sandwich, I got that. And I'm like, they kept the promise, yeah? This is a cheese sandwich. But sometimes it's really disappointing. And what I'm saying is that data protection API, it's that kind of a subject. So there's always a solution. There's always a hope that you're gonna get a good thing, but the road through it is very, very painful, yeah? So forgive me for the presentation, but we're gonna focus on the hardcore stuff, so no jokes anymore, and we are just purely learning what DPAPI is about. When you leave this room, I really hope, and I hope that this is your goal too, that you will know more about the DPAPI. That's my goal, okay? So, just a few words. Windows uses the following algorithms. Of course, it uses more, but when you do the research around cryptography, that's more or less what you are seeing. So when you kind of define that scope, you can predict that people who are writing the code on the other side, they can pretty much use one of these algorithms out there. So that's kind of nice because that narrows, in a certain sense, what you are actually dealing with. And whenever we are thinking about the data protection API, what we will need to discuss is what is it for real in Windows, yeah? So the data protection API, it's an API in Windows that allows you to protect your data in place whenever you are saving it through various applications or by using the operating system, yeah? So basically, whenever you are thinking about, for example, saving your password in Outlook or saving password through the browser, generically saying, or you are thinking about how your private keys are protected, this is exactly where the data protection API comes to place. And of course, question is this a safe mechanism? And data protection API in general is delivered in three places, three things. One, system DPAPI. Second, local user DPAPI, and third, domain user DPAPI. Because for the domain users, DPAPI is done in a little bit different way. So whenever we are thinking, of course, about that, question is, how do we protect these secrets? So we already know what are the secrets. It could be an Outlook password stored in the browser. Do you guys, by the way, recall software from Nearsoft? Yeah? Okay, some of you. Who does? Please put your hands up. I need to know. Okay, like seriously, 10%? Or you didn't have a breakfast or something? Okay, Nearsoft, please check it out, yeah? So Nearsoft is a software that allows you to basically extract the passwords from the browser and or Outlook, etc., Wi-Fi. Please check it out. And when you run it as you, then they give you your password. Let me start with this so that we are basically at the same page. So we're learning, let's do it. So this is basically Windows 10. And eventually, when we get into different tools that I have over here, I got a software called Chrome-Pass, and this is Nearsoft. So this is what I wanted to show you. If you want to recover your password, for example, because you stored it somewhere in the operating system, this is the software that will allow you to learn that particular password. Yeah? So Chrome-Pass allows me to extract information from the Google Chrome. Yeah? So we've got Freddy Krueger, password for LinkedIn, password. Yeah. So basically, what it says is that Freddy stored password in Chrome, and every single time Freddy enters LinkedIn, Freddy is logged on. Yeah. So this is the setup. Now, whenever we are thinking about the protection for that, what is absolutely important is the differentiation in between, as we mentioned, local user and the domain user. And this is something that we're going to be talking about. One principle here is very straightforward, is that this is a secret, no doubt. And that secret, it's going to be yours, it's going to be someone else. This is something that allows you, this secret allows you, of course, to log on to LinkedIn, but at the same time, what are the preconditions to reach this secret? Answer is, you need to be you. So when you log on, and you are logged on in Windows, and you open Chrome as you, that's the precondition to reach your secret. Even though it sounds very obvious right now, that's what we have to talk about. Let me give you an example from 2 weeks ago. I was in the US doing the penetration test for one of our customers, and I managed to become a guy, not a domain admin yet, but to be a guy who is in person a domain admin. So I had access to his account, regular account, not being a domain admin yet, and I was wondering, maybe he's connecting the roles somehow. So when I was him, I started to run different types of, for example, Nearsoft tools on his account. And one of the funny facts is that I was able to extract different passwords that he actually saved in Chrome, including a password to the Victoria's Secret account of his girlfriend. Yeah. So I was like, I mean, no, we could be thinking that it's maybe not very ethical, but yeah, okay, we can leave the discussion for later. Yeah. So anyway, and there were also some different passwords of whatever services he was using in the infrastructure, some like SCORE. I don't have to be a domain admin. I'm just gonna use these passwords to jump further. So let me explain you guys different things that are related with the data protection API and basically how does it work. So what we're gonna do right now, I'm gonna actually explain one simple thing which is related with the data protection API and how do we actually reach our secrets. And that's going to be quite interesting because I'm not very good at painting things, but we're going to actually leverage it this way. So let me whiten it, and we're going to do a little bit of a picture about how the domain user reaches its secrets. So the domain user does it in the following way. Domain user logs on. This one is going to be easy, of course. Yeah? So user logs on with the username and the password. What we've got, in a simple words, is that password is converted to the MD4, because Windows uses MD4, so the password's hash. Eventually, we're verifying if we can log on to the domain, yeah? Okay, user logged on, fine. What's happening next is that if the user has a password stored in a browser, let's call it a secret over here, then what's happening is that that password's hash, and that's crucial, protecting master key, that is stored in the master key container, and that master key is protecting a secret. So, simple conclusion is that our secrets are dependent on the strength of our password and the security of our account. So whoever is going to be you will have access to any of the secrets that you guys possess, including, by the way, and that's so important to say, all the applications that you run. And the question is, do you trust all your apps that you run on your account? Whatever that will be, 7-Zip, WinRAR, whatever that is. Yeah, do you trust the people that wrote these apps? Because you run them on the account, that means that these apps are able to get access to all of the other passwords that you have ever stored in your profile. Okay? Now, another part is, and this is interesting, there's another master key in the same master key container. So let's call it 1 and let's call it 2. Master key 1 is exactly the same as master key 2, but master key 2, it's encrypted with the public key of the domain. Now, this is where the fun begins, by the way. Imagine we work in 100,000 people organizations. Everybody, of course, is like a domain user. We all have account in a domain. We kind of sometimes store our secrets. We have Outlook. Each of us has Outlook. We've got Facebook accounts, LinkedIn, and so on. And we save all these secrets in our local browser. Yeah? We may be like, oh, I don't do it. I use KeePass. Okay, then you will not be the one. But then the rest are going to be. And this is really the point over here. So here is the question. Every single secret that we have, it's encrypted with the public key of the domain, which is, by the way, the same for 100,000 people. I'll prove it to you in a second. What's the threat over here? What's the question to be asked? Come on, guys. Question is, where's the private key? Right? Who has access to the private key? If you're going to have access to the private key, then basically you have passwords of every single employee in this organization. Let's talk about it. And let's demonstrate it. So how does it work? We're going to leverage over here a certain scenario that I would like to show you. And that scenario is going to touch base on the various aspects of DPAPI. So let me explain that. It's going to be super clear, but let's make sure that we are on the same page. So let me show you one thing first. I'm going to lock the desktop. You can see that I am a domain user here. Yeah. So I'm going to log on, Freddy. And let me show you the password. Password is password. yeah? And I'm logging on, and that's done, yeah? So I'm basically logging on to the domain, not a big deal. Now, I can see the password, everything is fine. Question is, where this password is actually stored. Where this password is stored. But we're going to talk about it in a moment, but this password is stored somewhere in the browser data and so on, and in the hacker's mind, we will need to get there and get this data. This data will be encrypted with our master key eventually, and then master key is encrypted with our password hash or the public key of the domain. So what I would like to show you today is how to get this private key of the domain and how you are able to decrypt every single secret of everybody that moves within your organization. Yeah? So let's do it. With this positive accent, we're gonna reboot this machine with one simple reason, because I would like to show you, indeed, in this scenario, that our secrets depend on our hash. Let me explain that. So first of all, what we're gonna do, we're going to reboot this machine. We could be thinking, well, BitLocker could help it. Yes, we can do this demonstration online and offline. So for this, BitLocker could help, but for the other scenario with a DPAPI, it couldn't. Yeah, so let's don't look at this from this perspective. Now, whenever we've got our Windows box over here, what I would like to do, I would like to change here cache logon data, and cache logon data, we're going to do command prompt. Let me just increase the font quickly. Here we go, font, bang, we got it. Cache logon data is something that we're going to use to log on when the domain controller is not available. Why do I want to show you this? Because if we're going to log on to the system by leveraging cache logon data, we can play with the password. So we're going to eventually log on with a different password, because I will override cache logon data so that when originally user logs on, user enters a password that I have pre-generated here. And the cache logon data, it's a value in the registry. Sometimes we call it cache credentials, but these are not credentials at all. We cannot log on with them. We can only compare with them. Yeah? So here we go. Let's dig in. So in order to be able to override cache logon data, what I'm going to use, and the tool that 100% you know, this is a Mimikatz, but this is our Securus edition. Here we go, where we're going to be overriding the cache logon data by setting the default password that is hard-coded in the tool, which is called Mimikatz. So let's do it. LSA dump cache, and we're going to override cache logon data based on Windows, system32, config, and then system. And let me explain you why system in a second. System32, config, security, and we're going to do /kiwi to override cache logon data. Now, why am I recalling over here system and security? Because when we look at the cache logon data, before we press enter, small explanation is needed. Within the cache logon data, it looks like this. So cache logon data is stored in the registry in the security hive. By default, it's 10 values. And that hive in general, or any type of something that we call a system secrets, they are encrypted indirectly with the boot key. And boot key is stored with the system hive. So this is why we are actually referring to the system and security in one command over here. So we've got a LSA dump cache, the Windows system32, config system, and security /kiwi, enter. Yeah, so we are done. Fantastic. So we have just overwritten cache logon data for every single user that is in this box. Now, just to log on with a different password, which has been generated with the cache logon data, I'm going to disconnect this machine from the network because I will need to log on with the cache logon data. Yeah, so I'm going to introduce a password that I already know in order to compare with the cache logon data within the registry. Bring it on. So we can just cancel this, continue, and reboot. In the meantime, while we are rebooting, let me show you how cache logon data looks like. First of all, in the registry, when we do analyze it, it looks like this. Cache logon data has a name. That name is called MSDCC2. And MSDCC2 is generated out of the function that you guys, I bet, know, because if you use KeyPass, LastPass, Key Vault, etc., you are actually using this function for your data protection. This is called PBK-DF2. While KeyPass, for example, uses SHA-512, Though, for example, in Windows for the cache log on data, there is a SHA-1. We could criticize on that, but to be absolutely sincere with you, I'm not working for Microsoft, so hopefully you know that this is not that bad. Yeah. So eventually, the complexity of this is good enough for us to be trusting the solution today. Yeah. So cache log on data, it's comfort for us, and don't be afraid to use it. Now, whenever we are thinking about our box over here, so let me just simply reconnect, because we're supposed to boot this machine already, and this is this one. Now, what I'm going to do, I'm going to log on Freddy Krueger, once again with the password. So if you remember, this is what we've been using over here, and this password is incorrect, because right now we are comparing with the cache log on data pre-generated value in the registry. So we're going to do mimikatz, like this. Here we go. And this is basically what we are comparing with. So what's happening over here right now when we log on, we're taking this value, we are calculating MD4 on the top of that, we are joining it with the username, on the top of that we are calculating MD4 back again, and we take this value, which we call DCC1 by the way, we take it together with the HMAC SHA-1, we take a username, we do 10,240 iterations on 16 blocks, and that's how you log on. Easy, right? Anyway, so we logged on. And eventually, what is next is, do I have access to my secrets? And if I do have, then that will be really sad. But data protection API, as we already explained, relies on our password hash. That's MK1, master key 1. And because our password hash is different right now, I'm not able to get access to my secrets. Second part though, so password is empty, right? Second part is, don't forget, we've got a master key 2 that is encrypted with the public key of the domain. This one, we're going to focus on in a moment. Now, please have a look, because this is really cool. This, we don't have a password, so we are like, meh, as a hacker, what am I supposed to do? My job right now is to find all these different secrets that are stored in your Windows and eventually figure out how to decrypt those. So let's focus on this. Now, question is, where do we have secrets? Where do we have secrets? So let's do it like this. As a regular user, I'm going to start a command prompt. You don't need to be privileged for that. And what am I going to do over here? Let's get into the CQ tools. Let's go to the DPAPI, and we've got a very simple tool that I really like, and this one is called CQ DPAPI Blob Searcher. And CQ DPAPI Blob Searcher, it's a tool that allows you to search through workstation, server, and so on for every possible secret that you might ever store. So question is, do I have any secrets in my laptop? Sometimes we may be thinking, oh, I'm not saving passwords in a browser. Every single time I open Outlook, I log on, etc. I don't save any passwords, any secrets. Well, figure it out. You can do it with this tool. So this tool allows us to specify a directory to be searched, so /d, and we're going to refer to, I'm going to shorten it a little bit, users, Freddy Krueger, app data, local, Google, because we are searching for secrets in Chrome. Yeah, so let's just give it a direct path, more or less. It doesn't have to be direct, but we're going to do it /r, which is recursively, and -o or /o to give it a folder where we're going to be doing the output of the secrets. Now, the next part I'm going to do to make it a little bit more convenient, DPAPI.txt, we're going to stream the whole output to the file so that you guys can see what we are actually dealing with, right? That was quite quick because we don't have that many secrets. Yeah, we can ignore it, it's not important now. Anyway, so we've got this one. I have disconnected from the network. So here you can see that we've got one simple thing. We've got a secret stored in cookies of Google. So Google Chrome user data default cookies. Now, this master key GUID is P55. Let's mind that, P55, it starts with that. And that is most probably the master key that is protecting our secrets. It's good knowledge to have. Now, what I don't like, and that's just my personal comment here, is that Chrome used SHA-1 and triple dash to encrypt my secret. That's not very convenient. I mean, I don't know how you feel about that, but I feel bad, yeah? But anyway, yeah, you will do what you want with this knowledge. Moving forward, B55, it's something that we will need to focus on. Okay, so let's see. What I'm gonna do start dot. Let's just open up the windows. When we're gonna dig into the percent, updata percent in the following path, guys. We're gonna go to the percent updata percent, which is Freddy updata roaming. We're gonna go to Microsoft, protect, SID, and this is a set of your master keys that you all use. Let me put it this way. Each of you sitting here, if you're using Windows, 100% you've got a key over there. At least one. Yeah? So check it out. If you want to do someone a bad joke, you go there and delete them all. And then it means that the other person will not be able to use the secret stored every single place this person will need to relog on. Yeah? I consider it as a good joke, by the way. But anyway, let's move forward. So if we move forward, we've got this. So B55. I marked this key over here like this so that I don't have to search for it for a long time. But this is this guy that we will have to get access to because this master key encrypts our Google Chrome, stored in the Google Chrome password. And I'm like, come on, I don't know the user's passwords, user's hash. I want to get access to this key. So how do we do it? And this is where the party begins because we will need to get into a domain controller and search for the key. Now, we could be, again, thinking, well, no, this is an attack where we have to engage a domain controller. Really? Think about it differently. If someone is a domain admin in your organization, that's what this person can do. So hackers, it's like a second problem over here. Yeah, that's A. B, what always makes me think is that if you do the pen test or if someone does the pen test for you and this person becomes a domain admin, this is a big trust relationship. That means that this person can potentially extract the private key like this and get access to all of the secrets of your organizations. Let's have a look. This one's going to be super easy because we've written this tool. It took a while again, but this tool, it's at the end so simple to be used. So with the CQ Elsa secrets dumper, we do file and we do exported PFX. Let me just put the dot here, PFX, enter. And this exported PFX, this is nothing but a private key of your whole domain. It's really something that if you're on a bad site, you would like to have. So if we do import it, we don't have to, by the way, but I just want to show you, yeah, how it looks like. Next. Password is secure, our company name. Next. Okay. And then cert mgr.msc, enter. We go to the personal, and then certificates, and then we can see this not available cute name certificate, which represents us the certificate that has been issued to nobody, by nobody. By the way, it's valid only for 1 year. Can we renew it? No. Can we fix this? No. Can we? No. Okay? So this is not something that you can fix, but you can monitor the domain controller and make sure that none of the code that you don't know is executed on the domain controller. Let's summarize it in a moment, yes, because it's not only that protection method which we can apply, and it's not the only problem that we are having over here. So this has been only issued for a year. So if your domain is like whatever from 2008, this is how old is your certificate over here, okay? And having this allows you to get access to the secrets of everybody else. Let's have a look into this scenario. We're gonna start a command prompt as a user back again on Windows 10. I'm back on Windows 10 right now. So we've got this exported PFX. I already copied this to this machine so that we don't have to do it. Now let me show you. We're gonna get into the CQ tools. We're gonna get to the DPAPI. Now, just to keep it super clear, in order to be able to get access to our secrets now, we have to take this particular master key, this B55, decrypt it with the private key that we grabbed from the domain, and encrypt it back with our current password's hash. Yeah? So this is the procedure. Quite straightforward, because when I'm logged on and I want to, on the fly, being able to get access to my secrets, I have to have these master keys encrypted with my current user's passwords hash. Let's have a look. So let's do it. We're going to do it like this. First of all, CQ hash calc, and our current password is Mimikatz. And let's just do 1. And Mimikatz over here, this is basically the MD4 of our Mimikatz over here, yeah? So of our string. So now I'm going to copy this. Now, what we're going to do, we're going to use over here CQ master key AD. This is our signature tool from our team. And CQ master key AD allows us to do the following. First of all, we're going to specify. We're going to decrypt the master keys with the PFX that we already have from the DC. Now, new hash, we're going to encrypt it back again with our current passwords hash. And file, I don't know yet, but let's have a look over here. We're going to be technically getting access to it by giving a path. So shift right click, copy as path in the command. So here we just do it like this, file, bang. Now, what happens when I press enter? Please have a look. Yeah, there is basically this new key created, AD modified. So what we will need to do is to replace this. So we do rename and underscore good like this, and we take this AD modified and we replace it. And basically our goal is going to be to give one more thing over here. So this is good. Do you want to change it? Yep. Okay, fine. And our goal is going to be to do one more thing, which is giving an attribute of a system and hidden, because otherwise data protection API will not treat it properly. This is a generic statement, but it's better to do it. Okay? Now, what we're going to do now? Well, basically, what I'm looking for, it's a Chrome pass, because we have just replaced our master key. We've decrypted it and re-encrypted it back again. Have a look. F5, I get a password. Right? What's the conclusion here? There are many, actually, and not all of them are positive. This represents the situation when someone has access to the domain controller. So if this person has access to the domain controller and has bad intentions, this person can decrypt every single person's password. Now, I really like to give my favorite scenario. We were also discussing this scenario with the guys on the training that we were running before the conference. And this is basically the scenario with, imagine one thing. If you would be a bad admin, maybe not you, but someone else, yeah? If someone's going to be a bad admin in your infrastructure, this person will take this private key and grab it, copy profiles from the file server or whatever of the users, or basically copy profiles of several users, log on to Facebook or LinkedIn or whatever you want with these people's passwords and accuse you of a sexual harassment. That sounds bad, right? So there is employee this says, that says. The other one says that you are not honest. The other one says that they are working in a hostile environment and it's your company and you didn't do anything. That's bad. So this is how you can put the company down by just having an access like this. Now, okay, let's put it aside. How can we protect ourselves? We can protect ourselves in various ways. Way number one is privileged access management. So making sure that domain admins, they're not humans, yeah? So basically these are the accounts that are logging on only on the domain controllers. We should even call them domain controller admins, yeah? Because that's where they should be. That's A. B, you need to make sure that whoever has access to backup in general in your organization doesn't have access maybe to the backup of the DC. So any members of the backup operators group, it could be a service that you are using in the organization and so on. Let me show you something in a moment. So let's keep it aside. It could be a backup service. Another one is whoever has access to the privilege of replicating directory changes all. This is something, guys, that you 100% need to check. And what we are talking about is the following. Yes? So when we've got a domain, let's have a look. Yeah, we're going to do it like this. We've got Active Directory, users and computers, and this is basically what we are over here referring to. Yeah. So replicating directory changes all. Yeah. And another part, number 4, is if you've got a read-only domain controller, you need to make sure who is logging on over there, because if there is a domain admin logging on, for example, this person can also pull out on the read-only DC the private key that is stored within the domain. So read-only domain controller requires additional protection over here. So these are the 4 things to have a look at. Now, data protection API system also comes to place. Let me close the circle of the problem over here. So when we do have a backup software, question is what kind of privileges this software has. Because what I would like to show you is the following. Yeah? We're going to get over here to the services MSC. And assuming that you've got some kind of a backup software, it could be anything. I'm just going to take this service, whatever. So we could do it this way. And I'm going to just type here a username. Here we go. Let's do it. Let's do it. This is a simple thing. Yeah, so we've got a PJ service running on some kind of a user. So that could be a backup software, your backup running on the service account, which is a backup software. So long story short, what we're going to do over here is, what we can do is, let's get into the tools folder. I'm going to use PSExec. We have also our own tool for that. It's called CQ Impersonate, whatever works. Not this one, no, but the exe. So we are starting the console as a local system because system secrets that are also related with the DPAPI are managed by the local system. Therefore, we have to get into tools and run CQ Secrets Dumper. This is a free tool available also in our blog. You can guys download it. This is one of our favorite tools. We just specify the service here, and then we specify PJ service, and then of course password comes out. Yeah. Now, also to connect the problem, we've got this service account. Do we make sure that the service account can only log on as a service in our systems? If yes, awesome. But in most organizations that we do pen test, that's not the case. So if I do steal this password, I can log on with this account somewhere else interactively, and then jump, do the lateral movement, maybe at the end manage to do the backup of the private keys from the DC that we were mentioning. Yeah, so that's another scenario that is a little longer, but not impossible. Yeah. So this is something that basically we wanted to discuss. Now, the next question of the universe is, okay, that's Data Protection API Classic. What about Data Protection API-NG? Isn't it better? Well, let me put it this way, it's different. It's completely different because it relies on a different mechanisms and different ways of communication with the domain controller, leveraging the KDS root key. So completely different concept in comparison to the classic DPAPI, but at the end, it's not that oftenly used in the operating system. So where do you use it? You use it in ASP.NET Core. You use it in BitLocker, for example, SID-protected drives. You use it, for example, within the GMSAs. You use it as well, for example, with the SID-protected PFX files. And this is something that I would like to show you at the end today, because this is a very good method as well to protect a PFX files, which, how do we manage passwords to PFX? It's such an old school type of file. Yeah, we just specify the password and that's it. But since Windows Server 2012 R2, you are able to rely protection of the PFX file on your own account, on your SID, through DPAPI-NG. Let me show you how we can do it. This is actually quite easy. So what we're going to do right now is I'm going to pull out a box like this. And this is who is logged on over here. Yeah, so we can check, we can see we are ready. Yeah. So what can we do? We can do certmgr.msc and we can do export our PFX. So I got some kind of a certificate. I can do all tasks, export, and then we can go next. And then we have a possibility to export the private key. By the way, even if you don't have a possibility to export the private key, that's not true because you can always grab it from the operating system's memory. So this is quite easy. Mimikatz in PowerShell can do it. So this is funny block over here. But anyway, yes, export the private key, next, and then next, and here's the thing. You've got over here group or users. So we can specify Freddy, or we can specify the password. In a classic way, we always specify password, but what we can do, we can export that certificate, that PFX, to be imported by these people here. So you specify these guys SID, next, next, and you save it in a file, yeah? So I already have a file like this, and this is this one, Blizzard. So if I open it as myself, I can go next, and this is really funny, by the way. This file has been protected this way. There is kind of a password, because this is a very old school way. This is a very old school file, an old school way of protecting it, and we can always display this password, and this one is called IXFGT and so on. This is the automatically generated password, which is protected by the SID protection by the DPAPI-NG. So at the end, file, it's still the same type of an old school file, but it's already better way of managing it. Now, question of the universe is, how can I steal this password? So if I see this PFX, because someone protected it in this way, I want to get access to this PFX. Is there a way to do it? And answer is, of course. Because if there is something that relies on a domain from that security perspective, then since we have access to the domain, we will be able to get access to this PFX password. So let me show you how can we do it. So I'm going to leave this for the moment open like this so that you can compare that this is actually at the end the same file. What do we need to have in order to get access to this PFX password? And answer is KDS root key. So the password, the KDS, the Kerberos key, the Kerberos data that is extracted from ntds.did. And in order to be able to extract it, we need as well a boot key, because ntds.did, both like SAM, for example, relies its security on the boot key. So how do we extract the boot key, and what's the concept behind it? Answer is very straightforward. We do it like this. I already have a copy of ntds.did made within the domain. Yeah. So let me get into my tools so that I'm able to, at the end, extract that particular data. What do I need to extract data from ntds.did? A boot key. So let me show you how to grab the boot key first. We grab the boot key in the following way. This is easy, yeah? So we take this domain controller or ntds.did or system on that domain controller, and we do it like this. CQ secrets dumper. So I guess you already know the tool from the service accounts password, but this time we're going to use it with a different functionality. That's the boot key, like this. And this is basically the string that I'm going to be using over here. That's simple, by the way. This is the boot key. Yeah, enter. So we got it. Now, over here, we're going to be working on ntds.did. So let's do it. So we're going to let me get into the tools, and we're going to get into the CQ tools, CQ_tools. Here we go. Fantastic. And then we're going to get into the extraction of the data from ntds.did. So for that, I'm going to use the tool CQ-NTDS DT Decrypter. By the way, you need to admit that our names of the tool are awful. It's so hard to remember them. We also have problems with this, but we have so many of them that we decided to put them in a descriptive way so that everybody knows when you look at the name, even though it's long, what does it do? Yeah. So here we go. This one is to decrypt the content of ntds.did. So we're going to do it like this. Boot key, bang, and then file, and then I got ntds.did over here, and then we can export hashes if you want, out file, hashes.txt from the ntds.did, but what is important for us is one more thing over here, which is related with the KDS root key and kds.bin, where we're going to be extracting the Kerberos root key. So we have extracted this already. And in a big organization, you can expect like 2, 3, 4 keys like this. And from one of these keys, for example, there is a password generated for the group managed service account. So 100%, you have it, yeah? So we're going to take this one, even though I know I have 3 of them, because I know that this is the one that I will need to use for the decryption. I just tested all of them literally, and then this one works, yeah? Here we go, so enter. And then we're gonna get into the tools. No, not this, CD, let's just get there. Here we go. And we're gonna do CQ DPAPI-NG PFX Decryptor. Easy to remember name. PFX, and we're gonna use this file that we were producing over there. So there is this bleCert PFX. And one more thing we're gonna specify is the master, which is actually our KDS root key. Done. Now enter, simple thing, you've got the password IXFGT. IXFGT. And if we do have a look at what we got underneath over here, it's basically IXFGT. So this is how you get access to the PFX file, which were SID-protected. Yeah. Now, what's the conclusion? Same conclusion as we discussed. Sometimes comfort, it's more important. Yeah. So this is a very convenient way of managing PFX files. Yeah, it's just like you don't even have to remember these passwords because you are who you are. You double click, you get access to the PFX. But if you have a domain admin or domain that is unprotected, that is not protected well, then this can violate so many different things. So that logically, more things you rely on it, the more that can be affected. That's why, yet another obvious conclusion here, we have to protect our domain controller. We all know that, but yet this is a very important reason for doing it. So this is basically data protection API and data protection API-NG that we have discussed. Now, one more last thing, if you don't mind, to show you a little bit of a cherry on everything, yes? So I really like to finish with something cool. At least I think so. So let's have a look. So what do we have over here? So this is basically KeePass. Now, I am not knowing the password for the KeePass of the user that is out there. I will try to type in secure so that we're going to be using it. And if I do click OK, it says the password is wrong. So I'm like, how am I supposed to get access to the user's KeePass? So either you're going to brute force the password if the user is protecting the KeePass with the password, or if the user is relying KeePass on a data protection API this time, we can always learn that by getting into the KeePass architecture. Let me just cancel it. Nope. And checking out protected user key. This is what is in the user's profile, and that's for real the key that protects the KeePass. And what you protect, it's not the KeePass database, but it's this key, right? So you encrypt this key with whatever method you provide. I can tell by the way how it looks, how it starts over here, that this is a data protection API blob. So I'm like, perfect. By having access to the domain of the user, what can we do? We can technically decrypt this KeePass by getting access to the user's data. Let's do it. You can be anybody you want to. I'm actually logged on over here as administrator, but it doesn't matter because we have access to the user's data. So let me show you something. What we're going to do over here, let me copy this. I got over here access to the master key of the user. We already discussed this. So master key of the user has been decrypted with the private key from the domain. This is this stage. I will not do this demo once again because I'm going to be repeating myself. Yes, so we have decrypted the master key with the private key of the domain. Done. That's where we start. Now, what do we do next? We go to the tools. Tools. And over here, we've got two tools. One is CQ DPAPI KeePass DB Decryptor. And with this tool, we are learning what's the entropy of KeePass. KeePass uses entropy, it's all the same, but it's there, so it's kind of easy. But the second thing we're going to need is the CQ DPAPI blob decryptor. And this guy takes two parameters, master, entropy, and blob, 3 parameters. So we're going to do it like this, master, and I have the master of the user here. We're going to do blob. And I have the blob of the user too, which is in C analysis, and this one is the protected user key bin. Yeah, and another one is, in this case, entropy, which we're going to get to. So I'm going to go a little bit up because the previous tool displayed it. So we're going to just copy that very in details. We got it. We go next. And entropy bank. Enter. Good. So this gives us a decrypted data, decrypted protected user key bin, which is directly a key protecting our KeePass database. We're almost there. So we're going to do it like this. CQ, and then all these names. DPAPI, KeePass DB decryptor. And this takes two parameters, K and F. So we're going to do K, which is the key that we have decrypted, bang, and F, which is simply the CQ base that we are using over here for the KeePass. So now what's happening, we are getting access to this particular KeePass database and decrypting it to the CQ base file. And this file, by the way, it's the one that we can enter. And if you put here a secure password, so again, our team's name, you're getting access to someone's KeePass, right? So I'm always confused a little bit that in a corporations and big organizations, sometimes there's an advice, use KeePass. Great, but people don't know if they're not working in IT how to use KeePass. The most pleasant thing for them and how to use KeePass would be to rely KeePass actually on a Windows logon. So that's even worse, because all of the passwords will be in one place. You don't have to use all these tools to gather passwords and secrets from all the locations. You can be like, okay, I'm going to just go to KeePass because this is how IT advised them. Yeah. So if you want to do or implement the password management in organizations, that is also something that has to be taken into consideration. I'm not saying KeePass is bad. KeePass is very good. It's just the way how sometimes we see that it's used, it's not very secure because it relies on factors that are not dependent on us, but dependent on someone else out there. And in security, there's a one unpopular word, and that word is trust. The less we have opportunities to trust in cybersecurity, the better, however sad that sounds. So with this positive accent, guys, just to give you the summary, this is our DPAPI toolkit. If you want to basically have access to the toolkit, you just need to get into our blog. This is where we share our tools. Summarizing, your computer, your DPAPI system is as safe as offline access or the privileged account. Your personal data is as safe as your password is or domain security is. Anything else requires additional monitoring, additional management, and by knowing how data protection works, we are able to pick a good way of protecting our data in the organization. And this is what I hope that you will do at the end, maybe after listening to this presentation, maybe reading more about it. It's a very difficult subject, by the way. You will not find that many information in the internet. So if you will guys have any questions, absolutely let us know. You can also take a challenge, participate in a quiz. You don't need to register. We like to have fun in cybersecurity. We always think with our team that sharing is caring. So we share our tools. You can always learn more. We have some videos over there, so check it out. And at the end, if you have any questions, then of course, please ask them in the applications that you guys have access to. So thanks a lot from my side. Thank you for being here. Thank you for listening. And I'm waiting for the questions to appear on the board. Thank you so much.